Okay, one more example of an inequality, and that is going to be a quadratic one. Let's take x minus 2 quantity squared is less than or equal to 9. All right, to solve this inequality, again, we can solve it a lot like we solve an equation. So we want to isolate x. So the first step would be to take the square root of both sides, right? That seems very reasonable. Okay, great. But remember how the square root of a square is simplified is always as an absolute value. This is a moment where, like, it's really important that you remember that sort of step that often gets forgotten. If you jump straight to putting a plus or minus on this expression, like if you do plus or minus x minus 2, the problem with that will be that one of them will have a correct inequality symbol and the other one will have the incorrect inequality symbol. It has to do with that whole reflecting business of like multiplying by a negative and flipping the symbol around. It has to do with that. So to avoid accidentally falling into that trap, we need to remember that this really simplifies as the absolute value of x minus 2, okay, and less than or equal to 3, right? So now we have to remember how to deal with inequalities involving absolute values. So the way I like to think of that is, let's say this is the absolute value. Let's kind of take this x minus 2, and that's a number, right? It's an algebraic expression, so it's a number. Let's compress that into just a single symbol. Let's just call it a. The absolute value of a is less than or equal to 3. What that means is that a is closer to 0 or exactly 3 units away. Closer to 0 than 3 or exactly 3 units away from 0. Let me say that again. It has to do with like the distance away from 0 is no more than 3, right? It's less than or equal to 3. So on a number line, I think it might be better to draw a picture. On a number line, if you have 0, you'll have like 3 on one side and negative 3 on the other side, right? And anything within this range right here is closer to 0 than 3 is, right? It's sort of like inside of that range, that 3 unit range. And it says less than or equal to, so being exactly 3 units away would be okay as well, right? So, so that a, whatever number is inside there, that number must be within this range from negative 3 to 3, right? So we could take that inequality and we could rewrite it like that. Okay, that's the equivalent way to write it. Now I'm going to take that a and expand it back out again. A was actually representing x minus 2, right? So let's write it in there with x minus 2. There we go. That's better. So now we've taken our what started as a quadratic inequality, took square roots and ended up with an absolute value inequality. We kind of simplified it a little bit, thinking of that expression as a single number, right? And made an argument about where that number must lie on the number line if its absolute value is less than or equal to 3. That turned it into a compound inequality that doesn't involve any absolute values any longer. So we're going to take that one, putting the x minus 2 back in again, and we're going to solve it. All we got to do is add 2 to all sides. Get negative 1 is less than or equal to x, which in turn is less than or equal to 5, and that gives us our solution. That was a, but now we're going to have the solution set with x and our interval notation negative 1 to 5 bracket bracket, like that. There we go. So that is the solution to the original quadratic inequality we started with. All right.